Okay, YouTube, this is my first video in a small unit that I'm doing on factoring, in which we're going to focus on factoring out the greatest common factor from an algebraic expression. So what I'd like to do is actually start by considering the following expression where we have 4 times x minus 3 and talk about how we would interpret something like this. Now, by the distribution property, we would have 4x times x, which would give us 4x squared, and then we would also have a positive 4x times a negative 3, which gives us a negative 12x. The thing I'd like to notice here is that we have an expression where each term in the expression, these are things separated by pluses or minuses, have common factors, and of course that common factor would be 4 because we actually sent a 4 through, but also an x. That is to say, if I were to say what does 4x squared and negative 12x have in common, they could both divide out a 4 and they could both divide out an x. So that being said, we say that we have this as a result, but maybe our goal is going to be this. Let's take an expression like this and break it up into two things that can be multiplied together to get this. And so noticing that they have a common factor, we can factor out that greatest common factor, which is going to be, as a matter of fact, exactly the opposite of distributing through. It's going to be working backwards and taking what they have in common out in front. So I notice because both of these terms have a 4 in common, we'll take it out front, and because they can both give at least one x, we'll take the x out front. And then what we write on the inside of this, since this is kind of the opposite of multiplication or distribution, we'll be dividing 4x out of everything that was in there. So the fact is, if we had 4x squared and we divided 4 by 4, we'd have 1 here, and we'd say x squared. If we divided an x out of that or took an x out, we'd be left with one single x. And then we would say negative 12 divided by a positive 4, that'd be a negative 3. And because we had this x here and we divided it out, then it would no longer be there. So the quicker way to write this would just be to say we took 4x out and we were left with x minus 3 on the inside, and we could always check this to make sure that we get back what we started with. So the idea is, can we take algebraic expressions and factor out the factors that they have in common? And we should always check to see if an algebraic expression shares a greatest common factor throughout all of its terms first. So on these here, it says factor the GCF out of each of the following expressions. We have this quadratic expression here where I notice that 4, 12, and 8 all share a common factor of 4. So we'll take the 4 out front, and then I look at the x's. This has 2 x's, this has 1 x, and this has no x's. So they don't all have an x in common. So 4 is the greatest common factor that they have. And then writing what's left on the inside, we'll just divide everything by this thing we put out front, this 4. So we say 4x squared divided by 4 would just be 1x squared. If we took this positive 12 and divided by 4, we'd be left with a positive 3 and that x. And then we divide a negative 8 by 4, we get a negative 2. And so this would be our factored expression where we've removed the GCF. So looking at this next one here, I look at the coefficients. Now this first one has a coefficient of 1, this has a coefficient of negative 3. So in terms of numerically, do they have a greatest common factor? Well, their greatest common factor numerically is 1. But I also notice that this has 2 x's here, x times x, and this has an x. So we can take one of those x's out front, work backwards here, and we would say that x squared dividing out an x would leave 1x behind. And negative 3x, if we remove that x out front, would just be the negative 3 part. And again, we could check this to make sure we get back our x squared minus 3x. And then this very last one here, I look through this and I say, well, coefficient-wise, the greatest factor that they have numerically is 1. But we'd say variable-wise, they each have 2 x's to give. So we could factor out an x squared and say that what's left is, well, x to the 4th, removing 2 x's is x to the 2nd. We have 2 left. Then we say negative 2x to the 3rd. If we took 2 of those x's out, would just be negative 2x to the 1st. And then this final one back here, because we removed the x squared, a lot of the time I get people that do this. They say, well, then there's nothing there. And that's actually a mistake. What we have to do is say, well, this positive 1, if we remove the x squared, I'm still left with a positive 1 right here. So checking this, we could redistribute and see that we get back to the initial expression.